Hello, Econ friends. In our previous video, we looked at the production function. And in the production function, we were looking at this question. As a firm adds more variable input to a fixed input, how is their output influenced or affected? In other words, in our little pizza factory story, as we hire more and more and more and more workers to work in our pizza shop, given that our pizza shop is fixed, as we hire more and more and more workers, what happens to our amount of pizzas made? And we learned that at first, the number of pizzas will increase rapidly, then it will decrease, then it will fall negative. And those were our three regions: increasing returns, we have them here, increasing returns, diminishing returns, and negative returns. We learned that production is really, really important because remember, every company has one primary goal. And that goal is to maximize profit, where profit is the total revenue and cost is the total cost of production. We know that total revenue is P times Q. And that's why over here, this column, which is output, which is Q, is so important. We studied the production function to figure out in part how adding more and more and more workers is going to affect the production and the output and therefore the revenue. But there's another part of that story. We saw over here that as we wanted to get more and more and more pizzas, we had to hire more and more and more workers. And hiring more and more workers affects our total cost. So we're now going to take our production function knowledge and we're going to extend that a little bit, and we're going to try to put some numbers onto what we're going to call short-run costs of production. So in this lesson, we're going to try to say, okay, what did the production function teach us? And we're going to try to not twist it, but we're going to try to figure out how those production function ideas affect the actual cost to buy something. First thing I want to do, take a look at the model that we're going to build up. We have a couple of simple assumptions. First things first, we're taking the exact same numbers from our first video. So if you look over here, take a look at this column here. We added 1, 2, 3, 4, 5, 6, 7, 8 labor. We see the labor right there. Notice that I stopped at 6 right here because over here, we learned that after 6, we went to 0 and negative. So we know we're not going to hire the 7th or the 8th worker necessarily. So we just cut them out. So the first thing to notice is we have the same level of labor. And now notice our marginal product. Get a pen there for you. So we had our variable labor goes up by 1. Our labor goes up by 1. Our total product went 0, 2, 5, 9, 12. Same thing here. So I want to make it really clear as we do this together. This sheet here is just an extension of the previous sheet. No new data, just extending it, okay? So the two little lectures will tie together. And therefore, what I want to do, I want to take these marginal product numbers and I want to transfer them here. So we're going to do that. So let's just fill in really quick. Our marginal product was nothing, and then 2, 3, 4, 3, 2, and 1. Remember that we said that diminishing returns kicked in right around there with our 4th worker. Keep that in mind, going to be important, okay? Now, with that said, we're ready to move on this. And again, what we want to do is we want to say in this sheet, in our last video, we had said, okay, we're going to make more pizzas. Now we want to figure out what's it going to cost us to make those pizzas. Now, the first thing to understand is we know that in economics, the short run, the concept of short run, it's not about the actual calendar time. It's not like it's a year or more or less. In economics, the short run refers to a period of time in which one input is fixed or otherwise cannot be changed. In contrast, in economics, in the long run, which we'll learn about later, in the long run, nothing is fixed. And the long run is the period of time in which all resources can be adjusted and the firm can add any resource it wants because nothing's fixed. Okay. So in the short run, one input is fixed. And as you recall, we were assuming that our fixed resource was going to be our capital, our pizza shop. In the short run, one variable is fixed, usually capital, and the other variable, the other input, let me start that again, forgive me. In the short run, one input is fixed, and we call that one capital in our model, and one input is variable, and we're going to assume that the variable resource is labor. And that makes sense. We're stuck in this pizza shop. We have a lease that's ours. We can't change it, but we can very easily bring more workers in or send some workers home and vary our labor. Okay, so one input fixed, one variable. And that's really important to know. And it's important to know because in economics, in cost theory, we're going to have fixed costs and variable costs. So it's important to know that in economics, we kind of break up cost as being fixed or variable. A fixed cost doesn't change no matter how much output you make. A variable cost changes in proportion to the output that you make. And one more time, we're going to assume that fixed cost is our capital and variable cost is our labor. So down here, let's clean this up. And down here, fixed cost is going to be our capital and variable cost is going to be our labor. Now, with that said, look at our assumptions. The assumptions that we've built up are saying that in the market, when we go out as pizza shop owners and we have to rent capital and hire workers, we're assuming that number one, our fixed costs are $200 a day. We're assuming number two, that we can hire workers, which is variable. We can hire as many or as few as we want, but no matter how many we hire, we have to pay those workers $100 per day. So once again, we're going to assume fixed cost of $200 per day and variable cost of $100 per worker. With that said, let's populate these two columns right here. Fixed cost, it's going to be $200. And that's not going to change. It doesn't matter how many pizzas we make. We have to spend $200 for our pizza shop, and that's a fixed cost. So that $200 goes all the way down. On the other hand, we can vary the number of workers that we hire. We can hire 0 or 1 or 2. It doesn't really matter. Labor, we can vary that. We can hire as many workers as we choose at a price of $100 per worker. We'll say $100 per L per day. So if we multiply 100 times this column, we'll get our variable cost. We hire 0 workers, 0 times 100, 0. No workers, no variable cost. If we hire 1 worker, 1 worker times 100 is 100. We hire 2 workers, 200. And you get the idea. We can take this all the way down, and by multiplying the number of workers that we hire times $100, we would get our variable costs, which should say 4, 5, and 600. So those are our variable costs. So now we've gotten a good start on this. We've broken our cost into fixed and identified that, and into variable and identified that. Now, ultimately though, remember, profit is equal to total revenue minus total cost. So while we want to break our costs down as fixed or variable, what we really care about is total cost. And that's right there. And total cost is going to be equal. So let's clean this up. Total cost is going to be equal to fixed costs plus variable cost. So we add them across, and we should get 200 plus 0, 200, 200 plus 100, 300, and on, and there you go. So all we've done here, we've created nothing new. We've just taken our existing fixed cost numbers, our existing variable cost numbers, and added them together because total cost is equal to fixed plus variable. So now we've got a really good measurement, and we've got a piece of data that might help us later on in our time together in this class, might help us later on figure out profits. So that's what we're building to. Now, before we can do that, we do need to go to a really, really important idea. And this idea, I'm going to do this in red. This idea is marginal cost. We've come across this idea of marginal before. We know that marginal means something extra. So back in this video, in this sheet, we learned that the marginal product was the extra output you got by hiring every additional worker. Same idea here, but now we're talking about marginal cost. Marginal cost is the increase in cost that comes from making each additional product. Okay, marginal cost is the increase in cost, the change in total cost, how much extra total cost you take on for every additional output, for every additional pizza that you make. So in our example, with our little pizza factory, marginal cost is going to be the additional cost that you have to incur to make each additional extra pizza. Or in mathematical terms, delta TC, the change in total cost, divided by delta Q, the change in output. But we know we don't need to be afraid of delta because we're just going to be subtracting. Subtract, and divide. We can do this. Okay? Now, we're going to crunch those numbers, but before we crunch the numbers, you might be asking yourself, why is marginal cost so important? That's a really, really important idea. Well, remember, one of the first decisions that we have to make as a business, in this business, for example, how many pizzas should we sell? How do we maximize our profits? How many pizzas should we sell? And I think the good rule of thumb is we should keep selling pizzas for as long as we're bringing more money in than we're sending out. We should keep selling pizzas for as long as each additional pizza that we sell brings more money in than it costs us to make. In other words, we're going to follow once again the marginal rule. And we're going to keep on selling pizzas for as long as the marginal benefit is greater than the marginal cost. Now, to be sort of technical, in business, the marginal benefit is really the marginal revenue. I'll make that cleaner. It's the marginal revenue. How much extra revenue does each extra pizza bring in? We're going to compare that to the marginal cost. So hypothetically, if we could sell pizzas for $10 each, and each pizza that you sell brings you in $10, you would sell pizzas for as long as your marginal cost was below $10. You're going to perform any action when the marginal benefit is greater than the marginal cost. You're not going to perform the action if the marginal cost is greater than the marginal benefit or revenue. So that's all to say that this curve here, the marginal cost curve, really, really important for our discussion later on how to maximize profit. So now let's crunch it. Now we know that you can never do a marginal on the first line. So we start on the second line. Look at this one. We're going from from 0 pizzas to 1. We're going from 0 pizzas to 1. And we're going from a total cost of 200 to 300. So our change in total cost at 0 pizzas, our total cost was 200. It's our fixed cost. It's going to go from 2 to 3. So our total cost is 300. Our change in total cost, 300 minus 200 is 100. Our change in labor, our change in quantity is going from, it should not be this one. Forgive me. That was my mistake. It's not this one. It's not the change in labor. It's a change in quantity. So we're actually going from here to here. Our change in output, our change in quantity is going from 0 to 2. That's 2 minus 0 equals 2. And therefore, since marginal cost is delta TC over delta Q, it's going to be 100 divided by 2, or $50. Let's repeat this a few times together. Suppose that we now go and hire the next worker. Well, if we hire the next worker, our total cost will go from 300 to 400. And our total pizzas will go from 2 to 5. So again, let's think about this. We hire a second worker. That second worker takes us from 2 pizzas to 5. So our delta Q is 3. That second worker brings in 3 pizzas. How much does that second worker add to our total cost? We go from 300 to 400. So 100. So by hiring that second worker, by hiring this worker here, that worker is going to give us 3 more pizzas, costing us an extra $100. The delta Q is 3, the delta TC is 100, and therefore our marginal cost will be 100 divided by 3, or 33. We'll do one more together, and then I'll just put the rest in, and you can make sure that you understand it and follow along. Let me get this clean for us. Now let's suppose that we go from 2 workers to 3 workers. At 3 workers, we now know we're going to have 9 pizzas. But how many extra pizzas did the third worker give us? Well, the change in output, the third worker took us from 5 pizzas up to 9 pizzas. So the change in output is 9 minus 5. All marginals, all deltas are just subtractions. So don't be freaked out by it. You can do this. The delta Q is going from 5 to 9. Therefore, it's 4. How much money do we have to spend? How much additional money did we have to spend to make those pizzas? Well, we went from 400 to 500. So you can see that we had to spend $100 more to get 4 more pizzas. And therefore our marginal cost, which again is delta TC over delta Q, is going to be equal to 100 divided by 3, and that's going to be 25. You can do the rest of these on your own. I'll give you the numbers right now. You can feel free to run the math and make sure you really get it. Remember our process. We're asking for each additional worker, how many additional pizzas will that worker give us, and what will be the extra cost. So that's what we're going to do. Really straightforward. Let's clean this up. And what you should get is we have 100 by 2, 100 by 3, 100 by 4. Sorry, I made a mistake here. Sorry, my error. That should be 100 divided by 4. I transferred the wrong number. Sorry about that. So it's 25. The next one will be 100 divided by 3 again, or 33, 33. And then 100 divided by 2, which is 50. And then 100 divided by 1, which is 100. Yikes. Hiring that 6th worker, that was kind of costly. We hired that 6th worker. We have 15 pizzas. The 6th worker only gave us 1 extra pizza. So for the 6th worker, the change in Q was 1, but the 6th worker jacked up our cost of production from 800, to 800 from 700. That's $100. Yikes. We had to spend $100 to make that additional pizza. That marginal cost was $100. That's an expensive pizza. Would you have, here's a question to see if you understand the concept. As a business owner, would you have been willing to hire this 6th worker? And your answer should be, well, the 6th worker, the marginal cost was $100. I would only hire that worker if I could sell that pizza for more than $100. And I'm telling you right now, my friends, that'd have to be a pretty damn tasty pizza to get me to pay $100 for it. So there you go. Marginal cost is done. Very important idea. Once again, marginal cost is going to be equal to the change in total cost divided by the change in output. It's basically what we have to spend to make each additional pizza. And that's going to be a really important concept in deciding what quantity, how many pizzas to sell, because again, we're only going to make pizzas if the marginal revenue that we bring in for making them is greater than the marginal cost. And that's why for this pizza here, $100 marginal cost, we can only make that pizza profitably if we can charge more than 100 for a pizza. And like I said, that better be a really impressive slice. Okay, so there we go. Final thing I want to point out is the shape. Look at the marginal cost. It starts off at 50 and then it falls and it bottoms out at 25. And then from 25 forward, or sorry, from that point forward, the costs rise. So we typically see marginal cost will fall at the beginning, and then it will rapidly bottom out, and then it'll rise. And once it starts rising, it keeps rising. So what I always like to say, if you were drawing the marginal cost curve, it's going to look like a Nike swoosh. When you think the marginal cost curve, think the Nike swoosh, and we'll label that MC. Falls at the beginning, rapidly bottoms out, and then goes up forever. Marginal cost curve, that's the Nike swoosh. Okay, let's move on. That's a really important curve. We've got a couple other ideas to go, and we'll be done. The next idea. Oh, first thing I want to do, I want to take my marginal cost numbers from here marginal cost, and I want to transfer them right here. Creating nothing new, we're just going to transfer those numbers over because we're going to do some comparisons. So we're going to say nothing, 50, 33, 33, 25, 33, 33, 50, and 100. Okay, so now that they're transferred over, we can move on to the next thing we're going to do, and that's average cost. Before we do average cost, I do want to show you one more little subtle, important detail. Kind of a tricky one to get your head around, but think about this. We had said a minute ago that marginal cost will fall and then Nike swoosh rise. Check this out. In our last video, we saw that marginal product will rise and then fall. You can think of marginal product and marginal cost as like a mirror. In fact, look at this. In this region here, marginal product is rising and marginal cost is falling. As the marginal product goes from 2 up to 3 up to 4, the marginal cost is falling from 50 to 33.50 to 25. So it's a really important idea. As the marginal product is rising, the marginal cost is falling. But as we know, eventually our old friend, Mr. Diminishing Returns, kicks in. And once diminishing returns kicks in, marginal products start to fall from 4 to 3 to 2 to 1. And look what happens. As the marginal product is falling, the marginal cost is rising. So we can say generally, as marginal product rises, marginal cost falls. As marginal product falls, marginal cost rises. They're a mirror of each other. Okay? Another way to say this is simply this. When a business is getting more and more productive, its costs will fall. As a business gets less and less productive, its costs will rise. And that's important for our consideration of profit. Okay? We have 2 more things to do, my friends, and we're going to go into a different color just so we can kind of make our marginals in red. I want to introduce now the idea of average. Okay? In economics, any average cost is the cost divided by Q. Any average is the cost divided by Q. So you got to be real careful. Marginal, you divide by the change in Q, but for average, you divide by Q. Notice that we have here 2 columns. We want to do average variable cost. Well, average variable cost will be equal to variable cost divided by Q. Notice that we have variable cost right here, and we have Q right here. I'll put that as well. That way we see it, because our output is Q. So we have average variable cost is variable cost, which is up here, divided by Q, which is right there. And we have average total cost, and that's going to be equal to total cost divided by Q. And we have total cost up there and Q right there. So all we have to do is just plug numbers in and we'll get our averages. Okay, let's do it. Now we can't divide by 0, so we're never going to have averages when we have 0 product. But for the rest of it, we just divide. So average variable cost for 2 will be 100 divided by 2, or 50. For the next line, 200 divided by 5, or 40. For the next line, when we have 3 workers and 9 pizzas, our variable cost is 300. So our average variable cost will be that 300 divided by the Q, which is 9, 33, 33. When we have a fourth worker getting 12 pizzas, variable cost is 400. So average variable cost will be that 400 divided by our 12. And that will also be 33, 33. 500 divided by 14, 3571. And finally, if we hire 6 workers, we're going to have 15 pizzas, a variable cost of 600. So average variable cost is 600 divided by 15 equals 40. Let's clean this up real quick and then we'll talk about that. So what we did, we created nothing really new. We just took existing data, plugged it into the formula for average variable cost, and we got our AVC, average variable cost. Let's talk about the shape. AVC starts off high at 50, goes down, bottoms out, and then goes back up. So AVC is a U-shaped curve. It looks like this. AVC. Starts off high, comes down, bottoms out, goes back up. So AVC is U-shaped. And finally, we have ATC. I'm not going to run the math for you. You know that it's going to be total cost, which is here. Oops, undo that. It's going to be total cost, which is these numbers here, divided by quantity, which are these numbers here. I won't plug them in for you. You can do those. You kind of get the concept now. I encourage you to do them. I'll just give you the answers and you can kind of check yourself. If you divide total cost by Q, you're going to get a blank line at first because you can't divide by 0. And then you're going to get 150, 80, 55, 55, 50, 50, and 53, 33. Notice the U shape. You see it. ATC starts at 150, falls, 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 bottoms out, and then starts to rise again. And if we had had more numbers underneath that, we would have seen that it looks like this. Actually, probably a bit more like this. A nice U shape that we would call ATC. So once again, much like AVC, the ATC is U-shaped. And that, my friends, is how you crunch out your curves. Notice what we've done here. We took production function data and output data, and then we applied prices to it. We applied the price of fixed capital at 200 a day, which gave us this column here. We applied the price of variable labor of 100 a day, which gave us this column here. We added them together to get total cost, which gave us this column here. We then did some really important number crunching. We got from total cost to marginal costs with this formula. And then we got from total cost to average costs with this formula. We learned that the marginal cost curve is Nike swoosh. Add that in for your notes. That's Nike swoosh. And that the average curves are U-shaped. We learned that the marginal cost curve is really important in helping us decide how much stuff to make. The final thing for today, the ATC curve, this ATC curve, I'll put it in black to keep it constant. This black, there we go. This ATC curve tells us are we making profit or loss? So we have three major curves: marginal cost, average total cost, average variable cost. They all have unique characteristics, unique shapes, and they all tell us something really important. Specifically, marginal cost tells us how many items to make, and average total cost tells us at that level of production, do we have profits? And if so, how big? At this point now, my friends, look what we've done. Going back up here, let me clean this up a little bit. Going back up here, we know that total revenue minus total cost equals profit. And now, after these last two videos, we know how to calculate output and production, and that helps influence total revenue. We now know how to crunch the numbers for total cost. And now we've got all the hard data that we need to learn how to maximize profit. And that's what we'll cover later on. Great job today. See you soon. Thank you.